Okay, today we're going to have a look at angles in a triangle. So previously we have learned parallel lines. There are 4 property theorems and 4 judgment theorems, right? And today we're going to have a look at the angles in a triangle. Probably we'll use the theorems we have learned to prove some of the property theorems in this lesson. So first of all, let's have a look at the related definitions. When we connect 3 points with line segments, we form a triangle. The points are called vertices of the triangle, and segments are called the sides of the triangle. The angles inside the triangle formed by the sides are the interior angles. So pay attention to this term, interior angles. If not specified, when we refer to the angles of a triangle, we mean the interior angles. For example, in the diagram on the right, angle A, B, C are the interior angles of triangle ABC. So usually we'll use this symbol to denote a triangle ABC. Okay. Next, let's have a look at what is an exterior angle. When we extend a side past a vertex of a triangle, we form an exterior angle of a triangle, such as angle XZP shown on the right. We call X and Y the remote interior angles of exterior angle XZP. So for example, in the diagram on the right, we have a triangle XYZ, right? If we extend this side to point P, then there is an angle called XZP, right? XZP is called the exterior angle. And angle X and angle Y are called the remote interior angles of exterior angle XZP. Okay, any questions?
No.
Okay, so basically these are just some trivial definitions you need to know, okay? These are to facilitate our discussion later. Okay, so there are, considering the angles in a triangle, actually there are 2 properties we need to know. So probably you have already heard of them. Property 1 is actually a theorem. Actually, we can prove this to be true. The sum of the angles in the triangle is always 180 degrees. For example, in this triangle ABC, sum of the interior angles A, B, and C is 180 degrees. Okay, so the problem is, how do we prove this to be true? Have you ever think of this? Have you ever thought of this?
No.
Okay, so let me regulate this problem here. Prove that the sum of the measures of the angles in the triangle is always 180 degrees. In other words, the question is, given a triangle ABC below, prove that angle A plus angle B plus angle C equals 180 degrees. Okay, I'll give you 2 minutes to think about this question. Okay, I'll give you a hint. So far we have learned 5 axioms, right? And 4 property theorems regarding parallel lines, and 4 judgment theorem also regarding the parallel lines, right? So these are what we have learned so far. These are the tools that we can use to prove any further property or theorems, right? So which one should you choose to prove this? Okay, I'll give you 2 minutes to think about this.
I don't know.
You know, okay, let me show you how to do this. All right, so actually we can draw a auxiliary line here, right? We can draw a line that passes through point A that is parallel to side BC, right? So let's say proof. We can draw a line. Call it K. Draw a line K through point A such that line K is parallel to segment BC. So why do I why should I do this? Because so far we have only learned the property theorems or judgment theorems regarding to the parallel lines, right? So the best way I can prove this problem is to introduce some parallel lines. Probably in the parallel lines, we have some congruent angles, right? So if I draw a line like this, line K, that is parallel to segment BC, because, so let's call this angle alpha. In order to facilitate our discussion, let's call this angle alpha and this angle beta. Because line K parallel to segment BC, we have alpha equals angle B, right? Why is that? Why is that possible? Can you see that?
Yeah.
Because alpha and angle B are, what do they call? They are called alternate interior angles, right? Of course, if you are already familiar with this, you don't have to write it here, okay? Because parallel lines indicates equal alternate interior angles, right? And also because line K is parallel to segment BC, we also have beta equals angle C, right? Why is that? Because angle beta and angle C are also alternate interior angles. The line AC here is just the transversal line, right? You see that?
Yeah.
Okay, because alpha plus angle BAC then plus beta is 180 degrees, right? Because this is just a straight angle. So alpha plus angle BAC plus angle beta is 180 degrees. Therefore, if we replace alpha using angle B and just keep angle BAC and then replace beta using angle C, then we have angle theta, angle B plus angle BAC plus angle C equals 180 degrees, right? And note here, angle B, angle BAC, and angle C are just the interior angles of this triangle, right? So in this way, we have proved that sum of the measures of the angles in the triangle is always 180 degrees. Okay, did you get it?
Yeah.
Okay, so basically the key to solve a geometric problem is usually by considering what we have learned so far, right? So what we have learned so far. We have learned 5 axioms, 4 property theorems related to parallel lines, 4 judgment theorems related to parallel lines, and now this new theorem here, right? I hope you can make the notes by yourself. And if you want to solve another geometric problem, you can always refer to what you have learned so far, okay? All right, so in practice, okay, I'll upload this note to Google Classroom. You can refer to my notes after this class, okay? And there is a second theorem related to the angles in the triangle. Second theorem states that any exterior angle of a triangle is equal to the sum of its remote interior angles. So for example, in this diagram, if we extend the side YV to point P, then this angle here is a exterior angle, right? This theorem states that angle XZP should equal the sum of angle X and angle Z, right? You understand? Any questions?
No.
Okay, so the problem is, how do we prove this is actually a theorem? How do we prove this is always right? Okay. Question is that, given such a diagram, prove that angle X plus angle Y equals X angle XZP in the diagram shown. Okay, again, you should use what we have learned so far to try to prove this. Okay, I'll give you 2 minutes to think about this question.
I don't know.
Okay, let me show you the solution. Remember that the key is to use what we have learned so far, right? So if I denote this angle here as alpha to facilitate our discussion. First of all, we know that the sum of the interior angles of this triangle XYZ is 180 degrees, right? So we can say in triangle XYZ, sum of the interior angles are angle X plus angle Y plus alpha. This is 180 degrees, right?
Yeah.
This is what we have learned so far. And we also know that angle XZP plus angle alpha also equals 180 degrees, right? Because this angle here is a split angle. Now, can you see how we can prove this? Can you see that?
Yeah.
Okay, so let's label this with 1 and 2. You can just use equation 1 minus equation 2. This will give us angle X plus angle Y. Then alpha is canceled with this alpha here, right? Then minus angle XZP equals right side. Right side is 180 degrees minus 180 degrees. So right side is 0. And this means angle X plus angle Y equals angle XZP, right? So that proves that any exterior angle of a triangle equals the sum of the two remote interior angles. You get it?
Yeah.
Okay, so you can make some notes and let me know if you finish.
Okay.
All right, so let's use these properties to solve some questions, okay? Exercise 1. One angle in a triangle is twice another angle, and the third angle is 54 degrees. What is the measure of the smallest angle in the triangle? Okay, you try to solve this. I'll give you 2 minutes to think about this question, and then let's discuss the solution, okay?
Um, 42 degrees.
Yes, 42 is correct. Okay, show you this. Let me show you the solution. You can check if your solution is the same with mine. Okay. In geometry, you can always draw a diagram to help you better understand this problem. So for example, we have a triangle ABC. We know that one angle is twice another angle. So for example, if I let this angle be x, x is unknown quantity, right? And this angle is twice of x, so this angle is 2x. Then the third angle is also known to be 54 degrees. Okay, according to Theorem 1, the sum of the three triangles here, which is 2x plus x plus 54 degrees, should equal 180 degrees, right? So that means 3x should equal 1, 2, 6 degrees. Therefore, x equals 42 degrees, right? But you don't know if 42 degrees is the smallest one yet. So let's compare all the angles here. X is 42 degrees, 2x must be 54 degrees. And the third angle is 54 degrees. So of these three interior angles, of course, the smallest angle in this triangle is 42 degrees, right? So the conclusion is the smallest angle in this triangle is 42 degrees. Okay. Any questions?
No.
Okay, then let's see the next one. Next one, we are given a diagram below where line M is parallel to line N. And segment AB is perpendicular to line M. And also angle ADC equals angle BCE equals 3x. Angle CEB is 50 degrees and angle BCD is x. Our task is to find the value of x. Okay, again, I'll give you 3 minutes to think about this question, okay?
I don't know.
All right, so I'll lead you to go through this problem, okay? All right, so first of all, note this is a straight angle, right? So if the left angle here is 3x, then this angle must be 180 minus 3x, right? If somehow we can express this angle in terms of x, then according to the sum of the internal angles is 180 degrees, probably we can solve for x, right? Can you follow me?
Yeah.
Okay, so in order to facilitate our discussion, let's call this angle gamma, this angle beta, this angle here alpha. So note here, because M is parallel to N, and M is perpendicular to segment AB, right? Therefore, we have alpha plus beta equals 90 degrees, right? Because these two lines are parallel to each other, and this is a transversal line. So this angle here and this angle here are alternate interior angles, right? Alternate interior angles are equal, so that means alpha plus beta should also equal 90 degrees, right? Can you follow me?
Yeah.
Therefore, we can express beta using 90 degrees minus alpha. Remember that our task or goal is to represent angle beta using x, right? So we need to establish the relationship between alpha and our x. Luckily, we can use the triangle BCE. So in triangle BCE, you know that the sum of the interior angles are 180 degrees, right? Therefore, we have alpha plus 3x plus 50 degrees equals 180 degrees, right? Can you follow me?
Yeah.
All right, therefore, we can successfully represent alpha using x. So alpha is just 180 degrees minus 50 degrees is 130 degrees minus 3x, right? Okay, if this is a relationship between alpha and x, if we put it here, that means we can represent beta also using x, right? Understand?
Yeah.
Okay, so let's call this 2 and this 1. Let's put 2 into 1. This will give us beta equals 90 degrees minus alpha. Note alpha is just 130 degrees minus 3x, right? So in this way, we know beta is 3x minus 40 degrees, right? Okay, so far we have successfully represent beta using x, right? And also note that because, okay, also note that 3x plus gamma is 180 degrees, right? Because this is just a straight angle. So that means we have gamma equals 180 degrees minus 3x, right?
Yeah.
So that means in triangle BCD, all the three interior angles can be represented using x, right? So it is possible for us to find the value of x. In triangle BCD, sum of the three internal angles are x. Then beta is 3x minus 40 degrees. Then plus the third one, gamma is 180 degrees minus 3x. And sum of these three angles, we know that according to theorem 1 is 180 degrees. So that's actually a equation in terms of x, right? So this gives us, let's simplify this. Left side is x, then plus 140 degrees, right? Right side is just 180 degrees. So that means x should equal 40 degrees, right? Okay, so what's the takeaway here? Takeaway is, first, we have used the property theorem of parallel lines, right? If these two lines are parallel, we know that alternate interior angles are equal. So this angle is 90 degrees. This angle is also 90 degrees, right? And the third theorem we are using is the theorem 1 we have learned today, which is the sum of the interior angles of a triangle is 180 degrees, right? So as you can see here, the key to solve a problem in geometry is just to use what we have learned so far, right? So you cannot just guess a problem blindly. Just think about what we have learned so far. So what are the given information? Based on the given information, what we can derive. You understand?
Yeah.
All right. Do you need some time to take notes?
Yes, please.
You let me know if you finish, okay?
Okay.
All right, then let's have a look at another exercise problem. So this time we're given a diagram below. Line AB is parallel to line DE. Angle BAC equals 2x minus 20 degrees. So this angle is given to be 2x minus 20. And angle ACB here is 30 degrees. Angle DF is x plus 55 degrees. So we are given these three angles, right? And our task is to find angle CED. So the task is to find this angle, CED here. Okay, again, I'll give you 3 minutes to think about this problem first. And if you like, you can write on the screen, okay?
I'm gonna go get my charger.
Pardon?
I said I'm gonna go get my charger.
Okay, no problem.
I don't know what to do from here.
Okay, then first of all, why you write x plus 55 equals 30? Why they're equal?
Because they're alternate exterior angles.
Okay, if this line is parallel to this line, you think this angle has some relationship with this one, right?
Yeah.
Well, actually, if you think, if you regard this line is a transversal, if you think this line is a transversal, then this angle must equal this angle, not 30 here, right?
Oh,
So 30 and x plus 50 are not alternate interior angles. Understand? And if you think about this line as a transversal, then this angle and this angle are alternate interior angles. Do you know what I'm talking about?
yeah.
Okay, so there is no apparent relationship between x plus 55 and your 30 here. So this expression is not correct. And I'll just follow your logic, okay? Think this angle here is 30 degrees. That's correct because they are vertical angles, right? Okay, this angle here is 2x minus 20 degrees. This is also correct because if this line is parallel to this line, and if you think this line is a transversal, then the angle here is a alternate interior angle of this angle. So these two angles are equal. Understand?
Yeah.
Okay. So let me erase this clear. All right, so let's consider this triangle here. Triangle CED, okay? If we consider this triangle, we know that the sum of the interior angles are 180. So one angle is 30 degrees. The other one, another one is 2x. So this angle here is 2x minus 20 degrees. So what is the third angle here? What should I put here?
180 minus x plus 55.
Yes, it's 180 degrees minus this angle here, right? Understand?
Yeah.
So 180 minus x plus 55. Okay, so this is an equation we can use to solve our x. So this actually gives us 30 degrees plus 2x minus 20 degrees, then plus 180 degrees minus x minus 55 degrees equals 180 degrees. So 180 degrees cancels with 180 degrees here. And 2x minus x is x. Then x 30 minus 20 is 10. Then minus 55 is minus 45 degrees. Equals 0. So that means x equals 45 degrees, right?
Yeah.
Therefore, angle DEF is known, which is 45 degrees plus 55 degrees, which is 100 degrees. Therefore, it is possible to solve angle CED. Angle CED is just 180 degrees minus 100 degrees, which is 80 degrees, right? You follow me?
Yeah.
Okay, so as you can see here, we have used the properties of parallel lines. If two lines are parallel, the alternate interior angles are congruent. Remember, when you want to use this property, you need to find the correct alternate interior angles, okay? And also we have used the property of the internal angles of a triangle. We have considered the triangle CDE, right? Okay, so actually there are a number of ways to solve this question. We can also use the triangle ABC here, okay? So let's have a look at the second solution of this question. Okay, I'll just write it here. Okay, so first of all, in order to facilitate our discussion, we can let angle CD be alpha, right? So that'll save us a little time to write angle CD. You can just use alpha. The target is to find value of alpha. Okay. Next, if we know line AB is parallel to line DE, here, these two lines are parallel, right? And this line here is a transversal line. Sorry about that. Okay, this line here is a transversal line. Then apparently this angle here is, which is alpha, and this angle here are alternate interior angles, right? If these two lines are parallel, then the alternate interior angles are congruent. So angle ABC which, is also alpha, right? You follow me?
Yeah.
Okay, then let's consider triangle ABC. In this triangle on the left, this time we're using triangle ABC instead of triangle CED. In this triangle, we know that sum of these three angles, which are 2x plus 20, 30 degrees, and alpha, is 180 degrees, right? And if we simplify this, we have alpha plus x plus 55 degrees equals 180 degrees. So as long as we can establish a relationship between alpha and x, that's possible to solve our alpha or x, right? And also note that x equals okay. Also note that the sum of alpha and x plus 55 degrees here is 180 degrees, right? That means we can represent x in terms of alpha here. Then we can put equation number 2 to equation number 1 to eliminate the x in equation number 1, right? That means we have an equation that only contains alpha. So it is possible to solve alpha in this equation. And alpha is 80 degrees, right? Can you see the logic here?
Pardon?
Can you see the logic here?
Yeah.
Okay. Do you need some time to take notes?
Yes, please.
Okay, let me know you finish.
Okay.
Okay, let's see the last question. Okay, we're given the following diagram. Task is to find sum of x plus y plus z. X is this angle. Y is this angle. And z is this angle. Okay, I'll give you 3 minutes to think about this first, okay?
Mm, 360.
Yes, 360 is correct. Okay. All right, let's write the solution here. All right, x is actually a exterior angle of this triangle ABC, right? According to the property 2, theorem 2, x should equal the sum of these two angles, right? So let's label them as 1, 2, or alpha, beta, doesn't matter. So we can say in triangle ABC, because x is exterior angle, so exterior angles equals the sum of the two remote internal angles, right? Interior angles. So x must equal angle 1 plus angle 2, right? And also let's consider y. Y is exterior angles, which equals, let's call this angle 3, which equals the remote sum of the two remote exterior angles. So y equals angle 1 plus angle 3, right? Then let's consider angle z. Z equals angle 2 plus angle 3, right? In order to find the sum of x, y, and z, we can just sum these three equations, right? 1 plus 2 plus 3 gives us left side is the target, x plus y plus z. Right side is angle 1 plus angle 2 plus angle 1 plus angle 3 plus angle 2 plus angle 3. Note this is just twice of sum of angle 1 plus angle 2 plus angle 3. Because we have already know that angle 1, 2, 3 are internal angles of this triangle. So the sum of the three angles is 180 degrees. Therefore, the result is 360 degrees, right? You follow me?
Yeah.
Okay, let me know if you finished taking notes, okay?
Okay.
All right, so before we leave, let's go over what we have learned so far. So far we have learned, first of all, Euclid's 5 axioms, right? Then in the parallel section, we have learned 4 property theorems related to parallel lines, right? And then for judgment property, 4 judgment theorems also related to parallel lines, right? Then today we have learned 2 theorems related to angles in triangles, right? I mean, in your notebook, you should have a collection of these axioms and theorems, okay? Because in your future study, whether you want to prove something or use what we have learned to solve practical problems, this is your basis, right? You should have a collection of these axioms and theorems on your notebook. If you haven't know any of them, please refer to my notes in Google Classroom, okay? I hope you can list them one by one and go over them after the class, okay? And the homework is to review these lecture notes and complete the following questions after the class, okay? I have already uploaded the homework onto Google Classroom.
Okay, thank you.
Any questions?
No, bye.
Okay, bye.